because what we're doing is we're solving equations. Stop.
Yes, ma'am.
We're solving equations that have trig functions in them. When I say solving, I mean we are getting the trig function down to it by itself, and then we're going to the unit circle and we're saying where the angle is. Okay? Before we dive in though, let's just refresh you on solving quadratics. This is from college algebra.
Hooray!
This is from college algebra.
Did it crash?
It did.
Yes.
It already crashed in the first place. This was so frustrating. It's like, I don't understand. I've deleted the software, reinstalled it, I've checked for updates.
At least the board doesn't power up.
Oh yeah, that one. No, they did not.
It just stopped.
It literally just crapped out on me that day.
That was so stupid.
Alright,
Oh, and we're still recording.
I know. Okay, so I think right here I wrote recall solving quadratics. Okay, refresher from college algebra, solving quadratics. You can solve by factoring, but that only works if it will factor. You can solve by square roots. If you don't remember when you're allowed to solve by square roots, it's when the bx term, it says term, is missing. That's when you can solve by square roots. And then of course there's solve by completing the square. I'm not even going to write that because it is a headache. And then there is solving by the quadratic formula. And if you need a refresher on what that formula is, x equals negative b plus or minus square root.
Oh, x is equal to negative b plus minus.
4ac. Oh, that's
All over 2a.
all over 2a. Hold on, that was crooked. All over 2a. The square roots one, I wanted to make sure you knew what I mean by when the bx term is missing. So I put one right here. So here is a quadratic equation, and if you notice that there is only the ax squared term, the bx term is gone. So we can solve by square roots here. Refresher, you have to get what's being squared by itself before you can square root. So in this case, the 4 is in the way. I would divide by 4 on both sides, and then I would take the square root. Now when you're solving, do you remember from college algebra what we said you absolutely have to include?
Oh, plus or minus.
Yep. You don't know where the 25 came from because we're solving. We have to account for the possibility that it was negative 5 times negative 5. So you're going to say plus or minus 5. Okay, like I said a second ago, this whole section, 7.5, you will notice has only one bullet point, and we are just solving trig equations. We'll just do a couple today, and then we'll call it a stopping point, and then tomorrow we'll do the rest. There's no two trig equations look alike, so that's why I put so many different practice problems on here. However, the steps in solving them they start out the same, and then it just depends on what type, like sometimes you end up with a quadratic nature, and it depends on, what you're looking at. So let's go to this slide right here. First of all, let's take some notes. First, isolate the trig function. So if you think back to when you're solving quadratic equations, you're trying to isolate the x. Well, in in this case, we're trying to isolate the trig. That would be the words sine, cosine, tangent, cosecant, secant, cotan. That's what you're trying to get by itself. Look at what we're looking at here. Notice the equation. You've not seen it before. 2 cosine x equals negative 1. I'm going to go ahead to the next one. 4 sine squared x equals 1. These are trig equations. So it's equations with trig functions in it. Okay? This is what we're doing now. We have a lot of notes to take here so that you can understand what it means to solve trig equations, and then we have fewer notes to take along the way. You're going to use the unit circle to figure out your answers. Then we're going to write our answers in degrees and radians, and then we're going to talk about it, what it means in terms of the graph. So coming up here, let's do the algebra part first. We want to get, and I'm going to use my highlighter. It's up to you if you want to highlight this as well on your paper. We want to get cosine x by itself. So what's in the way? 2. How's it attached?
Multiplication.
How do you move it?
Division.
All right. So cosine x would equal negative 1/2. Right? So basically what it's asking is, what angle has a cosine value of negative 1/2? Let's actually write this. Let's come over here and let's write, what angle has cosine equal to negative 1/2? That's how you read the equation. Well, if we're doing what angle, that means we're actually doing cosine inverse, so we have to be careful here, right? Go to your formula sheet. What is the restriction for cosine? It's which quadrants?
1 and 2.
1 and 2. So I'm going to copy right here that cosine runs from 0 to pi. Let's start going back to writing in pi every now and then, okay, so that you don't forget pi is 180. So in 7.4, look at your unit circle. In 7.4, I'm going to make a note right here. In 7.4, and I'm going to box it in. What we did here was we found cosine inverse of negative 1/2, and we came up with one answer, right? We had one answer from 7.4. This is familiar territory, yes? Okay, 7.5 is, now we're solving the equation, and we're going to find all the possible answers. So let's draw a picture here of quadrants, and then I just want you to draw an entire circle as best as you can. Then I want you to label that this is 7.5. I'm trying to show you the difference of 7.4 and 7.5. And then I want you to put underneath that we're finding all the answers. We're finding all the possible answers in 7.5. 7.4 was just tell me the one. 7.5 is what is everything that works. So we've not actually solved this yet. We're going to come over here. You have the trig function by itself. I'm going to draw an arrow to say, like, now at this point, you would, that's a terrible arrow. We'll draw a better one. Let's try it again. That was better. You're going to use the unit circle to figure out the first two answers, and then we're going to write something fancy to address all the answers. So go to your unit circle. Tell me
120.
where is cosine negative 1/2?
120.
And 240. 120 and 240. Watch how I write this. Don't write big, by the way. 120 and 240. Now we could go ahead and write the radian as well underneath. So what would that be? 120 is 2 pi over 3. 240, what is it?
4 pi over 3.
4 pi over 3. Alright, so this is, come back up and focus on degrees. How many answers do I have here? 2. But we said we're addressing all, which means, now, let me see how I drew it last year. Okay, so watch this. When you look at it completely drawn, you're going to be like, what in the world did she do there? But as I'm drawing it, if you'll watch, you'll understand it. I'm going to draw, and I'm going to move. Hold on. We'll draw a unit circle. Okay. 120 lands quadrant 2. 240 lands quadrant 3, right? Okay. So watch. All right. So 120, 240. What could I do? What's coterminal? What does that mean? Coterminal means add what?
360.
360. So there's 120, add 360. There's an answer.
That's stupid.
No, it's not stupid. There's 240, add 360. There's an answer.
That's stupid.
What could I do again?
Subtract 360.
So I could go the reverse. You see what I mean? I told you that when you look at it drawn, you'd be like, what did she do there? I was showing you that basically it's hitting every coterminal angle. Okay, so we have to account for that right here. So in degrees, you would just say plus 360. Now you've got to address, if I just write 360, that's just once. I need to address
X.
twice. Yes. We're not going to use X though, because we've got X here. We're going to use K. But basically you're saying times K, and K would represent any number, any integer. Nice pretty number on the number line. Here we would say plus 360K. It also covers negative numbers.
Ugh.
So if you wanted to subtract 360,
Do we not
K
put
would
plus?
just be negative 1.
Do we just put plus minus 260?
Yeah. No, just put plus, because K can be any integer. So if I want to subtract 360, K would be negative. Now over here, we're going to do the same concept, but we're in radians.
2 pi.
2 pi. And then I'll put a K. So I'm going to draw a big old squiggly to say right here that K, do you remember how to write this, is an element of the integer family. Do you remember that? Yeah, write it down. It's not something that you necessarily, like have to be good at to do well in this chapter, but it's good to practice writing it. You're saying that K can be any integer, and that would be the nice numbers on the number line. Now what you've just done, now we took a lot of notes here. This was the first one. They normally don't have this many notes. You just solved this equation for every single value, period, no matter how many coterminal angles there are. Look at this picture over here. This is showing you the graph of it. The left side of the equation got graphed, so basically the amplitude got turned up on a cosine function, and then the right side of the equation is this horizontal line right here, y equals -1, and the solutions are where it's crossing, and now you can see why there's so many answers. You see every time it's crossing, and those keep going, so it's going to just keep crossing. So this is what it looks like graphically. So that's it in a nutshell. Now let's just practice the different levels of difficulty in the problem. So let's go to the next slide. it helps to go in and ask yourself, like, what is the actual trig function? Because that's what I need to get by itself. I've got to get sine squared to be just sine.
You're gonna what?
Take a nap
What do I need to do first?
for a long, long time.
Divide by 4. And then what do I do?
Take the square root.
Mm-hmm.
Onto them. And I have no idea what the square root of 1/4 is.
Yes, you do.
1/8.
Wait, reverse it. Reverse. 1 half.
Oh yeah.
You can square root.
That's so stupid.
Don't let a fraction throw you off. Remember, you can square root anything. Period.
I give up.
So, square root of fraction, all you have to do is separate and square root the top and square root the bottom. So right here, this would be the sine of x equals. Now be careful though.
Plus or minus.
There it is.
Duh.
You've got to remember to put plus or minus there.
So it's literally going to be like 40.
And then it would be 1/2. I want you to make a note over here. Note. Plus or minus means any given quadrant. The fact that we have plus or minus here, it means that we are looking in all 4 quadrants. Okay? All right. So, if you need help with this, I'm going to write the question that you would ask yourself over here. What angle has a sine, which is what letter? Sine is which one?
Y.
A y value of 1/2 or -1/2. So that's the question you're asking yourself. We are going to write our answers in both radians and degrees. So I'm going to separate these.
Darn. I give up.
I'm still
We're going to write our answer in radians and degrees. How many quadrants are there? See how I'm setting this up?
I hope you enjoy your ability to talk.
And I know that it's 4 because it said plus or minus.
Take your ability. Solve my problems. We help it.
Bless you. So go to your unit circle. You're looking for where y is positive 1/2 and negative 1/2. And you're writing those down. And then I want you to write the whole fancy to address the coterminal angles.
I'm done. What do you think waterboarding feels like?
I don't think about stuff like that. I play outside.
It happens outside. I mean,
It happened inside too.
Yeah, I think people that are doing that don't really care about the mess of things.
you could do it either place.
I would drown. I would choke.
I mean, you could also hang a tire swing inside.
All right, what did y'all find
Oh, I did that.
in? Let's do radians. What'd you get?
5 or 6.
Okay. Yep. There
Can I
it
do
is.
the degrees, please?
They can be
Yes,
in
Ed.
any order, but it does help as you're trying to check off, like, have I covered that quadrant, just to spin around.
I don't know why. I just went to
So this only addresses 4 answers. We need to address
Every single answer
all
ever
answers.
made.
So you would say plus 2πk. Now, when we take this end of chapter exam, it is on paper because my math lab exam is a nightmare once again in this section. And so you would get partial credit if you get majority of the credit. If you gave me the radians, but then you left off, like if it says write an expression for all answers, then you would have to write the plus 2πk. You would only lose partial credit if you didn't write that. Okay, so the bulk of it is where is it landing? And then the full circle is addressing coterminal angles. All right, what's the degrees?
Get it, Brady.
30, 150, 210, and 330. Did I get it right?
Yeah.
Yes.
Judging.
I do have a question.
Yes.
You have a question?
Mhm.
Let's
Let's see. We're going to make a note where k is an element of the integers. Was there? So I have a question,
Alright.
and you may need a visual here. Hold on.
Oh, today is Wednesday.
What was the first radian?
All right, Luke. I wasn't
Closer
fine.
to next to me.
Okay, so here, here, and here, right?
Maybe I'll just waterboard myself.
Okay, I have a question. Don't answer out loud. I want everyone to have a second to think of an answer.
I'm listening.
So I said these 4, and then we said plus 360. That gave us 4 things to write. Is there a more succinct?
Nice.
What does that mean?
Succinct?
What does that mean?
Condensed?
No.
That's a word. Is succinct a word?
There's no way.
It is a word.
There's not a
I
condensed
knew
version,
it.
though.
Short.
Oh, Pierce. But it's so Pierce, he's succinct.
Condensed. If you, let's say,
We gotta call him succinct.
reading the book, or a succinct way of understanding is asking Albert, right? Okay.
Leave it 9
It's
minutes.
a condensed way.
9-minute
Is
nap.
there a more succinct way to write?
No.
Yes.
Oh, you answered the question.
Can anybody think of a creative way that I could write these 4, I can represent these 4 values without writing 4, I can write it in
Oh,
2.
2.
I see it. Can I answer it or no?
Hold that thought. I want everyone to have a second to think. I want to know if you can be creative and come up with a way to address these 4 markers. When I say markers, I mean like hit this, hit that, hit this, hit that. But can you do it in 2 ways?
I can answer.
Yeah, I have a feeling you're on it.
So you would take pi over 6,
Okay.
or 30 degrees, and then you could add 180 to it,
Ah.
and it'd be plus 180k. And then
Okay.
you take 150 degrees, 150 degrees,
Okay.
and you do plus 180k.
There it is. Okay. So if you didn't see it. So let's come over here. If you didn't see it, we were trying to come up with a way to hit these 4 markers, but only in 2 ways. And it all has to do with the reference angle. The 30-degree angle could just get added with 180 to hit the 210 angle.
What do you think
They
these
have
kids
the
that
same
watch this
reference
on the
angle.
video think?
And then the 150 angle can get added with 180 to hit the 330. So basically the polar opposite ones, you can condense into one expression. So now what would that look like over here?
I'm a bully.
Over here, you would say to yourself, let's see, I'm just going to come over here and say, or, ... If you had pi over 6, you don't add 2 pi, instead you would add
Pi.
pi, okay? Or 5 pi
Well, that's like
over
a frat
6
house thingy.
plus pi k. So that is a shorter
28.
way to do it.
This is the same as the segment before.
These two responses will cover
That's
all
so much
four.
fun to say.
So that is another way. You don't have to go that way,
Adi.
but if you see it, by all means, go that way.
I see nothing.
Like over here, it would be 30 plus 180k, 150 plus 180k, and that will cover the 210 and the 310, and you don't have to write those. Okay.
We just stop. We got 5 minutes. We got 5 minutes.
I have 5 minutes. Yeah, we can stop.
Yes.
The other practice problems tomorrow.
I've been stopped for like 20 minutes.
I can't wait to use this video to make a AI voice of you.
I can't wait.